Thank you very much. Good morning, everyone. So, thank you. Well, as you can see on this first slide, I'm not Marcio. I just wanted to very quickly say that the original speaker, Marcio, had a medical issue last night, so I'm going to cover for him today. He's actually the supermaster on databases, but I'll do my best and try to explain you the content that he prepared for you. So today we're going to talk about building with purpose-built database. And before we got into that particular topic, I wanted to spend a few minutes just trying to show you how we build services in AWS and how that it relates in the overall philosophy of the company. So I'm not sure if you ever seen this flying wheel from Amazon.com. And for those of you have never seen it before, or you have seen it, let me just very briefly explain what it's about. It's the philosophy and the root of Amazon.com itself. So the first thing happens when you have a great customer experience. When you have a great customer experience, you will generate traffic to your site. Imagine that you have an e-commerce site. That will happen to have sellers trying to sell your products on your site, and that will give your customers with a lot of different selections capabilities, and that really improves your customer experience because they can have multiple choice for all the things that for all the different needs. And not only that, that also creates growth. And that growth reverses in being able to lower the infrastructure costs, and that lowers the prices, and that low prices we can revert back directly into the customer, having, again, better customer experience. And this is a virtuous cycle that happens on, and it's the philosophy behind Amazon.com and AWS. In AWS, we have done basically the same. 90% of the services that we have comes from direct customer feedback. So our product teams listen to the customer, listen to their needs, and just build what they need. 90% of those things that we build comes directly from where a customer tells us, hey, I really need to do this. And we do that over and over. We iterate our services, and we provide you with a lot of different options, a lot of different choices. So you have a good customer experience. You have different tools for your choice, and you can select many, in this case, databases suitable for different use cases. When we have many customers using these services, we start to have a growth, and you have to have a lower cost structure, and we can lower our price, and give that lower price to you, creating, again, a real nice customer experience. And this is what it's all about. Up to today, we have around even more than 40 services related to data, and it's integrated in a platform that has around even over 160 services. They are fully integrated, they operate together, and as you can see over the presentation, we've tried to make the life easy for you when you try to work with data. So back then, when we're trying to design the services that will be handling data, what would we think that will be the major trends that will affect data? So one of the first things that we thought is there's going to be an explosion of the data. And in fact, there has been an explosion of the data. But we thought that this will be mostly driven by smart devices. So wearable devices, smart homes, smart watch, smart screen TVs, everything is going to be sending data. And in fact, we thought that it will be an increase of per 10 every 5 years in the volume of data that's going to be generated, and you will be needing to manage to extract value from this data. The second thing that we thought that was going to happen is that microservices is going to change everything. So we thought that, and it's still happening, is that big monolithic applications were going to be broken down into smaller chunks, into smaller problems, where smaller teams of developers will be trying to solve those problems. And to be able to be flexible and agile solving those particular problems, they will need a tool at hand. They need a different choice of tools because each of these small microservices that compose a big application will solve different problems. They will need different tools to solve these problems. And another thing that we thought is that analytics cannot be an after-the-fact thing. We really need to have analytics in real time. We really need to know what's going on your company and your customer in any given moment in order to improve, to iterate faster. The last thing that we thought is that there's going to be a fast, rapid rate of change coming from DevOps. Because with this new DevOps philosophy, with an automatic chain of continuous integration and delivery, The data will be started to be generated really fast, really changeable. It will be started to be consumed really, really quick. There will be a lot of changes in your application. All of this is going to be changing and changing the environment, and all of this is going to happen really quickly. So we need to be prepared for that. And how did we get prepared for that? So back in 2010, what we did. So of course, there's going to be an explosion of data. So what we do about it? The first thing that we thought is, and we did, is we're going to build services that help our customers to handle this explosion of data. And as an example, we built Redshift, which is a cloud data warehouse capable of exa and petabytes capabilities. The second thing that we thought about is that in the cloud, we cannot think of architectures as we think of on traditional architecture. We need to change things, and we need to think differently. We need to think about scalability and high availability by default. And that's what we did, and we built DynamoDB. And finally, and probably as a conclusion, we thought that will be one size fits all. That doesn't really work. So we started to build purpose-built services for different use cases. And that's what we did also with databases. And we built Amazon DynamoDB, as I said before, because in around 2005, we started to have problems scaling Oracle RAC. Started to have serious problems, so we needed to solve the situation, and we built our own tool, our own tool at hand, our own purpose-built tool, and then we wrote a paper about DynamoDB, and it's free, you can read it, it's from 2007, it's really a nice read. So our approach to this, and our approach to offer you these services is really, really, really easy. The first thing is we architect our services from the ground up into the cloud. So as a company, we don't have a legacy, we don't have an on-premise, things that we need to kind of retrofit for the cloud. No, our services are built on the cloud, for the cloud. So for example, one of your customers or yourself, they start with a small prototype. They can scale to 1 million users very, very easily with no changes, with no major changes in their application, with no major changes on their architecture. That's how we will build our services. The second thing is that we're going to offer a portfolio of things that are optimized for your use case. As again, it's the same concept as before, so there's not one single tool that can match all of your use cases. We really need to provide you with something that can help you to optimize your operations. We try to solve all your particular problem, so we need to build a portfolio, and that was our approach, to build tools that you can choose from. The third thing is we help you to move faster with managed services. There's a term inside AWS which is called undifferentiated heavy lifting. If you haven't heard this before, this is related to all the tasks that you do that is not the core business function of your company. Managing servers, installing servers, all of those things are probably not the core business of your company, but still you spend a lot of time doing that activities, patching, versioning, handling different versions. So what we do with managed services is we take care of that. We give you the service, and you take care of improving your application, of innovating, on using the agility of this capability, and don't take care about the other layers. We take care of that. And finally, we also thought that all the customers will come with a previous infrastructure, will come with something already being built, operating on-premise. So we need to give you the tools to be able to come to the cloud easily and smoothly. And we give the tools. So we'll see them later as well. So overall, when it comes to data, we have a very broad and deep portfolio of solutions that you can choose of, ranging from around 10 different ways where you can move your data in AWS. You can do it from the internet with transfer acceleration, with dedicated networks through MPLS, through Snowball devices, through Kinesis to kind of do streaming of data. We give you with different options when it comes to databases, and we're going to go through all of them. We give you with, and we're going to talk about that topic slightly. We give you with tools to build your own data lake, and to build also and to operate ledger services. And we give you the analytics tool to exploit all your data, to use all your data. And we give you also different options when it comes to visualize all your data, and even use machine learning on top of that. You train your models, deploy models, whatever you want to do with the data, we'll help you to do that. But one thing I wanted to mention is that when we see applications today, when we see modern applications today, we need to think a bit differently. It's not exactly as we thought of in the past. So I'm saying the past, I'm a bit old, but probably a few years ago later. So a few years ago, when you thought about a big application, a big deployment, probably we're thinking about 5,000, 10,000 users on an ERP, on a CRM application, and so on. Well, that's big. But when you deploy and you plan your applications in the cloud, one thing that happens is that it can, as I said before, it can start with a small prototype because of the global nature of the cloud, because your users can access your application anywhere. It can scale up to 1 million users very rapidly. Tell this to Airbnb. So they started with very small, and they become, massive. And this is one of the examples. Tell that to people like Netflix and how they started, and now they handle millions of users, a data volume on storage that can run from tera to exabit. So the idea is your applications are global and needs to be used by global users, and we have global needs. We have our different request rates. We go from milliseconds to microseconds and many other things that you will want to do in a pay-as-you-go and provide your developers with an instant API access so they can really work inside their coding very smoothly and very agile. So basically, this is what we wanted to do with databases. We want to give you the right tool for the right job and also for analytics as well. The right tool for the right job. So as you can see here, it's not possible to deliver Amazon Fresh with a big Caterpillar. So it's exactly the same when you think about your use case. Probably the relational database doesn't fit everything, or the NoSQL database doesn't fit all the different use cases. So let's think about the use case. Let's think about the database that you need and see what different uses and different options we have. Let's get a little bit deeper into it now. And we see around 7 major use cases of data right now. And let me describe some of those very lightly, because we're going to go a bit, but just a bit deeper into them later. So the first case is, of course, relational data, relational databases. It's self-explicative. I don't think I need to explain that. But we still think that it's a very important data store. So we think that most of the data out there stored in databases is still stored on relational databases. It is good when you need referential integrity, when you really need ACID transactions. It's really, and there's a lot of use cases when you really need a relational database, of course. But think about another different type of use case. You need a key value store with high throughput, with low latency, where you can search by key. This is a total different use case. For example, on online gaming, for example, real-time bidding, where you need to maintain a shopping cart for multiple users. That's a different use case, and probably not being handled properly by a relational database. Then what about a key value database? Then another use case can be a document store. Maybe you need to store documents and index documents, and you need to be able to search your documents by any of the attributes in there. In a content management system, on a personalized content system, for example, you need to do that. So in order to do that, you will use a document database, most probably, because it will help you to solve your problem. Another case is when you need in-memory database, because milliseconds latency is not good. You need microseconds latency. You need really fast calculations. Think, for example, again, in online gaming, think on leaderboards. Think, for example, on having real-time analytics. And a very, very powerful example is caching. When you need to do caching over a database, for example, you really have milliseconds and microseconds latency. You use in-memory databases. Another use case is graph databases. So though it seems like this is new, this is not really new. The concept of graph databases has been around for already some time. But the computational capabilities did not allow this to happen massively for a number of transactions with scalability up to now. So right now, we are able to offer these services. And it's about discovering and using the relationship between data to solve problems. This is, for example, obvious in a social network scenario. But it's not so obvious and really helpful in scenarios like fraud detection. And let me tell you something about it. So for example, in fraud detection, many of our customers use machine learning. And through machine learning, they can understand patterns, and they can predict, and they can tell, well, I think in this situation, fraud has been committed. But still, you don't have the proof. You can't go to the judge and say, listen, fraud has been committed. So in order to get the proof, what the customers do is to try to understand the relationship between the data, how the data has been moved from one place to another, what's the actual relationship between the data and the persons, and they do this through graph databases. It's one of the major use cases for graph databases. Another use case that you might have is time series. You may have to store time series, log and collect series of data. Think, for example, of a manufacturing environment. In a manufacturing environment where you have coming data from your devices, from your sensors, and IoT is another typical scenario. And lastly, but not least, is the ledger. So you need to provide immutable proof of record transactions. Then you use kind of one of the ledger databases that we're going to show you later. This has several applications, system of records, and also financial applications, as you might expect, blockchain, and things like that. So for all of those cases, our strategy is very simple. So we give you the tools. We give you a plethora of tools that you can use for each of the use cases. And you can choose if they solve your problem, and if not, you can choose another one. We think that these are the ones that better solve your problem, but still, you can use, you can test. Maybe you have options. That's the good thing about it. And we provide you with these options to you, so you can really integrate those into your development and into your applications. So at this moment, let me go a little bit deeper in some of those databases and use cases that we just mentioned before, so give you a little bit more of information. We're talking about relational databases. The first service I'm going to mention is Amazon RDS. Amazon RDS is a managed relational database service. This means that it allows you to create a production-ready relational database in just 2 or 3 clicks. And you can create this relational database on around 6 different flavors, ranging from an Oracle relational database, a SQL Server database, PostgreSQL, SQL Server, MariaDB, and also Aurora, which is a special one we're going to cover in the next slide. So what's the good thing about a managed service like RDS? It's super easy to administer. So you don't have to worry about the infrastructure, about the servers. You don't have to worry about the OS. You don't have to worry about the software of your database. You don't have to worry about patching that software, maintaining the versions, backing up, handling the patching, and so on. So we take care of that, and we provide you with a very easy-to-use console when you give us a couple of data, a couple of things, like, for example, which is the maintenance window where you want to do the backup. And that's the kind of things that you will tell us, and we will handle the rest. And you will give you also some APIs, well, you can also integrate into your development, and in case your developers wants to control the database actions through APIs. It's very easy to use and very easy to manage. And in terms of availability and durability, it's replicated across availability zones. For those of you who are not familiar with availability zones and how the global infrastructure of AWS is managed, just let me do a very quick comment about it. Each AWS region has at least, or is typically composed by 3 different availability zones, which are isolated places in terms of risk handling zones. So for example, one availability zone from the other will be in different seismic risk plane, different flooding plane. We'll have a different electricity and power provider. We have a different internet provider. So failures in one place are not, in any case, propagated to the other. Are completely isolated in terms of risk and disaster zones. Yet they are connected by high-capacity connectors. And they are, in fact, able to handle your workloads in different availability zones. So when we use availability zones, we provide you with high availability. We provide you with the capability to have your data replicated in different places and provide you with better availability. We automate the backup for your data, and we also automate the failover. We are able to switch the endpoint when something's going wrong on your database. Another thing is that it's very easily and highly scalable. With a couple of clicks, you can scale the compute and the storage capacity of your database, but also many of these engines will allow you to very easily create read replicas to offload read capabilities for your applications. And all of this with no downtime. And then in terms of speed, it's really fast. So you can use, for example, SSD disk in order to have better access to disk, and we can also provide you with guaranteed IOPS and provision IOPS. So you can really have a consistent and expected performance on your database. And in terms of security, you can even run it inside a VPC, an isolated VPC with no connection outside, and get into the database itself by an IPsec VPN tunnel if you want to. Or you can even be in a private network inside your VPC and be called only from a public tier. So you can create multi-tier applications where the database is not visible from the outside, which in fact is the best practice to build with this kind of architectures. It's super secure in that sense. And let me talk a little bit about Aurora. Aurora is another managed database that we provide as part of RDS. And what Aurora comes from. So our customers were telling us, well, we're using MySQL, we're using Postgre, but we don't see this is really enterprise grade. We don't see this like really useful for enterprise ready. And for that, we're using another type of commercial applications. So we thought that the customer was telling us, I really need some commercial grade database that is based on open source. And that's why we built Amazon Aurora. So in the outside for your developers, they still see the usual eSQL or PostgreSQL interface. Nothing changes there. The changes is in the inside, in the way we have made the architecture of the services. In fact, in terms of performance, Aurora is around 5 times faster, better performance than standard SQL, and 3 times PostgreSQL. And when it comes to availability and durability, you're going to see in a moment the architecture, but it stores your data in 6 different places, two times in each availability zone. And it kind of separates the compute from the storage, providing you able to scale independently as well. And it's highly secure, so you can provide network isolation with Aurora, as I said before, but it's also integrated with some services like IAM, like other services, KMS, Key Management System, in order for you to cipher, in order for you to encrypt your data, and so on. And the most important thing here is also that it's a fully managed service, so you don't need to do anything. Just give us a couple of clicks, get Aurora running, and that's all you need to get it up and working. About the Aurora architecture, not going much into the details, but as you can see here, both the masters and the replicas of Aurora, they share a storage volume. This storage volume is composed by hundreds of storage units, and if your chunk of your data is distributed twice across each availability zone. Remember that each availability zone is an isolated zone where the disaster recovery probabilities between them is really low. They are kind of built for that. And the most important thing is that having 6 copies of your data across 3 availability zones allows you to be prepared or to be prepared for disaster of availability zone +1. There is a whole quorum thing inside it, on read-write quorum, not going into the detail, but it will protect you against failures of 1 availability zone +1. And going a little bit further into this, also Aurora allows you to do something else. So with Aurora, and in a matter of seconds, you can replicate your tables in another region. Let's say, for example, you are working on Ireland, and you got a lot of use base in Frankfurt, and you want to replicate your tables there. So in less than 1 second, you can replicate your tables there. And it's very easily, just a couple of clicks. And this will provide you with a global cross-region replication in case that you need further and increased availability. But also will provide you with lower latency to the users that are consuming the tables on the region where you just duplicated your data, which is really great. But what happens with the databases that actually live in private data centers? So we still think that they are kind of difficult to set up, mostly when it comes to build for high availability or distribute it across multiple nodes. Still, that's a challenge for most of those. It needs to have technical people who are able to understand that particular databases, that operating system, that softwares, and able to maintain it. And it also is kind of a burden because sometimes you will encounter that you are working with different versions, and some parts of your organization use some versions, some other parts use some others. You have to patch it, you have to come back and forth. and it's not easy to manage. So we came with something called Amazon RDS on VMware. So what this brings to you? This brings to you a fully managed relational database, but on your private data center, on your common use VMware tools like vSphere. So what we provide you here is a fully managed relational database in any of the 6 flavors that we just mentioned before, but in your data center, easily to provision and easily to set up and get it running. And as I said, you can use your common tools, and common tools data center like operated by VMware like vSphere or something like that. So this will provide you with a lot of scalability and increased performance, because it will be very easy to scale the compute and storage capacity on your private data center. And you can even use the AWS platform to burst database capacity into the cloud, or even create replicas of your database into the cloud to serve your content globally, not only on your private data center. And we'll also tap into AWS for increased availability, for creating kind of a hybrid environment when you can use your private data center on AWS for backing up, for restoring, for creating high availability scenarios, and so on. This is a hybrid environment that really allows you to have the best of both worlds. And in situations in which, for some reason, for some compliance reasons, your the database cannot get out of your data center. It needs to be there, but still, you want to have a fully managed, resilient, relational database from the cloud. You can use this. You can use Amazon RDS on VMware and have, as I said, the best of both worlds. And then we have Amazon DynamoDB, which I already mentioned before, but what it gives you is a NoSQL database. Amazon DB is a NoSQL database which has performance at scale and will give you high throughput with a very, very low latency. And it's built to give you milliseconds response time with any scale. It scales as much as you need, and it's totally serverless, so you don't need to provision anything. It's one level of abstraction further the managed services. So you don't need to provision anything. You just tell us what's the read and write capabilities that you want, and we are able to provision and serve and scale that for you. It's by default encrypted. And one thing that you can do with Amazon DynamoDB is that you can create global tables. Some concepts sound similar to what we've seen before with Aurora, but you can create tables that are distributed regionally, so the latency of your users in different parts of the world are decreased. You have cross-region, again, availability, and this is really super easy to set up. It's just a couple of clicks on the console or one IP call. The other type of database that we mentioned is the Amazon DocumentDB, another fully managed database, which in this case is a document database, and it's fully compatible with MongoDB 3.6. It's fully managed. Again, it's nothing that you should provision, nothing that you should maintain. We take care of that, and it's really scalable. So with DocumentDB, you can create almost 15 replicas to serve all your read needs. And it's really fast. So we estimate that it's around twice as fast as a MongoDB, traditional MongoDB database. When you talk about in-memory database applications, we have a service, a managed service again called Amazon ElastiCache for Redis and Memcached. In this case, what we do is that we use open source projects and we get them and manage those for you. It's like a Memcached or Redis, and we give you sub-millisecond response time, microsecond response times for your needs, whatever it's caching, real-time analytics, on any other use case. This is, again, fully managed, super easy to scale, and it's secure and compliant. You can use this inside an Amazon VPC. You can use this to encrypt and transit. You can use it encrypting on rest. There's a huge opportunity here to create and to innovate while not having to worry about how you manage a in-memory database. The other thing that we mentioned before is graph database, and that's Amazon Neptune. Amazon Neptune is a graph database, a managed service. And one thing I love about Neptune is that it really makes things really easy. Graph mathematics and setting up a graph cluster with any other tools can be really difficult. This is a managed services that makes things really easy for you. In first place, it supports querying with Gremlin and Sparkly with really is an easy interface and a very common interface for most of the developers. And in the other hand, it's very open. So it supports Tinkerpop and also supports RDF, which makes it open to all the projects that are currently being developed. And it's reliable, as we see with Aurora. Your data is replicated 6 times across all the 3 availability zones, and it's very fast. So got millisecond latency for querying millions of relationships, and even billions of relationships. When you go into an Elasticsearch service, you need an Elasticsearch service, we could provide you with a fully managed Elasticsearch service. The main characteristics here is that it's really easy to use. A couple of clicks, and you have an Elasticsearch fully managed for your business. It's not really complicated. It's just a couple of clicks, as I said. It's totally open, and it has a set of different APIs that you can log, and you can plug in things like Logstacks or Kibana if you are working with that. And it's totally secure. It integrates with most of the security services that AWS platform has, and it provides you with great availability. Timestream is another managed services. In this case, this is our managed time series database. So Timestream, we think that it can handle around 10 million insertions per second. That makes it 1,000 times faster than traditional database, and at a much lower cost than traditional databases. So Timestream is designed to handle trillions of events. This means that the query engine and the rest of the capabilities inside Timestream will be adjusted to serve your demand in a predictive way of serving. So you cannot expect peaks, or you can expect decrease on your performance. It will adapt to provide you with a predicted performance for your application needs. And it has some built-in functions that will help you on your analytics. And again, this is a serverless service. So you need to manage anything, you need to provision anything. So you won't spin a single server in order to start using Timestream at all. So what happens when you need to provide immutable system of record, transactions, transparent, that are verifiable through cryptography? So in that case, you may use Amazon Quantum Ledger Database. This is the major use case for Amazon Quantum Ledger Database. And one thing that I love about the service is that it's really easy to use. So you just go into the services, you just define your tables, and there's nothing else. We auto-scale, we provide the provision, we provision every resource, we auto-scale to your needs, and you don't have all the complexity on building such a database from the scratch, which, believe me, is not always easy. And one thing that we think or we notice is that it can handle 2 or 3 times the transactions that the ledgers do in one of the most common frameworks out there. Still, you might need to have, or you might need to want to work with blockchain. So when thinking about blockchain, again, it's not easy to set up. You need to think about your servers, you need to think about the operating system, how you create the network, which framework are you going to install. So it's not really easy to have it set up and running. Amazon Managed Blockchain is a managed service. Again, we take care of that for you. You just take care of using the services and leveraging the capabilities. And currently, we support the Hyperledger framework, but also the Ethereum framework. It's stable, it's super secure, and it's integrated with AWS KMS. KMS is a key management system which basically handles the encryption keys for you, and it's a two-tier key management system in which a master key will create custom managed key, and you will always have this kind of two-tier security. But with all of this said, what if you want to move all your databases, because my session has been so good that I convinced you want to move your data to the cloud, and you really want to do it. You have a lot of options. You have a lot of relational database. You want to move up there. And the question is, okay, Daniel, but how do I do that? How can you help me to do that? Well, we have a service called AWS Database Migration Service. With this service, customers by themselves are able to migrate very complex databases built on the premise to the cloud and very easily. Still, if it's something very complex scenario, of course, you can use some of our partners that will help you through this migration. But AWS Database Migration Service is a really cool service. We'll migrate your on-premise databases to the cloud smoothly. We'll migrate between types of databases. And not only that, it will also help you to convert the schema. Things very subtle and very small, but still very important. For example, in Oracle, the table names are capital letters. In Postgre, this is lower letters. So you will notice when it's not working. So we'll do the schema conversion for you. And data replication allows you to kind of have a replicator instance, replication the data between the target and the source. And only in the moment in which the developer changed the endpoint, which is the new endpoint, the database in the cloud, is when the data will be fully sent to the cloud. So it's almost zero downtime migration. It's no loss of your data in all of the process. And we talk a little bit and a lot about data, but what about analytics? What about making sense of all of this data that we have stored in multiple purpose-built databases? So when it comes to analytics, traditional analytics looks like you can see here. So you will probably have some enterprise systems that were putting your data into data warehouses, probably relational data warehouses, and they will be consumed and exploited by business intelligence tools. Okay, so first of all, they will mostly be relational data, which is totally okay, but we'll be talking about gigas or terabits scale, and going further than that, it becomes really expensive in terms of storage. So a lot of the data has been not used, has been made redundant, has been thrown away, and most of the data could be used to get better insights, to enrich other data, to get better predictions, to get better analytics. But in terms of cost and things, so it was thrown out. So what's our approach? Our approach is data lakes. Data lakes use Amazon S3 as the primary storage services, which has 11 nines of durability, and have exabyte capability and virtually unlimited scalability as well. So in Amazon S3, you can store your data, whether it is structured, non-structured, whether it's relational, not relational, and data coming from any part of your organization. So not having silos anymore, silos of different departments storing in different types of databases. It's a place where you can plug in different analytics tools, purpose-built again. So you're going to do Hadoop, you're going to do Spark, let's do it with IMR. You want to do exploratory queries, let's use Athena. You get a plethora of tools to exploit and make sense of this data stored on Amazon S3. And very important, it's super cost-effective. It has different tiers, but the top tier starts with 2.3 cents per gigabit. So make your calculation. It's really cheap to store all your data here and not throw away anything that could be useful to get your insights. And we thought even further than this. Building data lakes can be daunting or complex by the first time, so we wanted to make it easier for you. So we launched something called Amazon Lake Formations that takes you to build your own data lakes in a couple of days. So Amazon Lake Formation is kind of a dashboard. It's a kind of a single tool that will allow you to start moving your data, to making sense of your data, to catalog your data automatically. That will help you to enforce all the security policies, the access, the restrictions to your data, and to start applying the tools to get insights from your data automatically. So we'll help you with that through lake formation, instead of you going, exploring, and building the data lake by your own. Lake formation is really great. If you can, please do take a look. And almost finally, I wanted to speak about Amazon Redshift. Redshift is a cloud data warehouse. As I mentioned before, it's built on petabyte scale, and it has several key characteristics. The first of all is that is the virtual unlimited concurrency. So this virtually can handle all queries, all users working at the same time on the cluster. And I'm going to show you in a moment how we approach that virtually unlimited concurrency. The second thing that is great about Redshift is that it extends over the data that you have. Let's say you have data inside Redshift, and of course you can do your your analytics there, you can do your complex query, your complex join, but it can also go further than that. It can go into the storage, Amazon S3, as we said before, the data lake where all your data is there. And even without putting your data inside the data warehouse, you can join and make queries that queries the storage server itself and the data warehouse data itself, and join that into a single query, into a single result, which is really great and helps you not to have to bring the data into the database. And something that we see is that 10 times the performance of normal data warehouse with a tenth of a cost, and this is something really attractive. How Redshift kind of handles this concurrent scaling? So basically, it does by when you have a cluster running and you have a peak of performance, you have a peak of queries, users, you need more capacity. You don't have to worry and kind of launch another cluster yourself. Basically, what Redshift, if you allow him to do that, is to launch something that is called concurrent scaling. So we will create another cluster, it will copy the data for you, and will respond to the demand. Once the demand is over, it will be destroyed, and you will go back to normal operations. And we think that 90% of the Redshift customers will get this for free, because every 24 hours you're running Amazon Redshift, you get 1 hour of this scaling for free. And we don't think that you have peaks that takes longer than 1 hour. Maybe it's a batch process that happens at night, or something that is really making you scale a little bit further from your needs, but it will not be something sustainable over the time. And this is Spectrum, which is just exactly what I mentioned before. Spectrum is another capability of Redshift that allows you to have in your data, structured, non-structured, wherever, on S3, make a query that takes into account not only the data that is inside Redshift, but also the data that is inside your Amazon storage service. You can join those data in a query, and you can do that at any scale. And something very cool about Redshift, as has been out recently, is that we apply machine learning to help you tune your data warehouse. Tuning the data warehouse, finding the right configurations, making efficient and usable is not all the time is really easy. So we help you with ML-based auto-tuning. It will happen behind the scenes. It will do the analysis. It will vacuum you behind the scenes. But we will provide you with recommendations to increase your performance, to increase the way that you work with and reduce your cost. And finally, I wanted to mention Amazon AMR. So if you are working with Hadoop or Spark on your analysis workloads for your analytics, you already know how complex it can become to launch the cluster, to install the tools, to maintain the tools on the latest version. So it's kind of, as we said before, undifferentiated heavy lifting. Your value comes from the analysis that you do on your data, not from having this app ready and running. So with Amazon AMR, it's really easy to set up cluster in a couple of clicks. You set your cluster up and running. When you finish, you just destroy them and you are done. You don't have to have an infrastructure running all the time for 2 or 3 analyses per day, for example. They use Amazon S3, what you mentioned before, for storage. So you don't have to bring all your data to HDFS storage on the servers. It will connect directly with Amazon S3 for the data. It's really, really a low-cost service, even more if you use EC2, the spot instance. This is instances that come to you over a bidding. You get this instance when you get the price. And we commit to you to use to bring you the latest versions on the frameworks and the community has released under 30 days. So before 30 days are over, the latest tools that the community has out, you will be able to select those into the platform. So as a summary, and I'm going to finish with this, we have more than 40 data-related services. We have a lot of them. But it's about providing you with a tool that is better for you. It's about understanding your needs, and which is the purpose-built database that will work in your particular case. And this is something that is powering up 1,000 and 1,000 customer applications. So please, I hope that this session gives you a very high-level overview of some of these tools. And now you can go and investigate a little bit deeper if you have identified one use case, what particular database will help your needs. And I'll be happy to talk about it. I will be around, so happy to go deeper if you need to. Thank you very much for your time and for attending this session today. That's all.